One of the new topics in the APM PMQ, it's coming with box 7, is the idea of VUCA. VUCA is volatile, uncertain, complex, and ambiguity in projects. So in this talk we're going to look at what is VUCA, what it means for projects, and a little bit of how we can manage projects in this volatile environment that we now all find ourselves living in. So VUCA is quite an old term. It came from the end of the Cold War, when the US military said that the certainties of the Cold War no longer applied, and that the world was very different, and that the threats, the military threats at that time, were more diverse and more difficult to predict than they were in the past. And then this is a search graph from Google, and what you can see is over time it's got a more common term. It's been used more and more. In fact, probably after the crash in 2008, the level of volatility and uncertainty that we all faced went up, and so it became a more and more common term, and it was accepted in general business management rather than that specific military context. So what do we mean by volatility, uncertainty, complexity and ambiguity? So volatility means something's rapidly changing in an unpredictable way, something in the project environment. So for example, future indications of performance may not be relevant anymore. So things may have changed. So we may not be able to use our historic measures for the future. Uncertainty is more that we're unsure what the range of outcomes are likely to be. So we might know that we need some materials, or we might know that we need to do some form of testing, but we're not too sure how long that will take, or if things will go wrong or not. Complexity comes from the fact that systems are made up of many components, and that complexity comes from the way those different components interact with each other. And ambiguity, well, ambidextrous, ambi means having something having two meanings. So that means that given the information that we have, it could be open to different interpretations by different people. So let's just look at those in a little bit more detail. So I've done this little graph. This is showing volatility. So I thought of a price of labour. So you might be paying £100 a day for some labour, and as you can see, the volatility is quite dynamic. This is something I did in Excel. So what price would you use to for your cost modelling? Because the price that you have today would be changing wildly, and you might think this is quite unusual, but if you look at oil prices recently, they've gone through a similar sort of graph, and so silver and things like that are quite volatile at the moment. Uncertainty is slightly different from volatility. What uncertainty means is there might be a best case or a worst case or a most likely case for the cost of something, and we're unsure what that uncertainty is. But uncertainty may also apply to we're uncertain to what the requirements are going to be, or we're uncertain about a particular piece of technology. So it may not be just associated with a number, but it may be that we're not sure how long a certain activity will take or how difficult it's going to be. Aspect going back to volatility. Volatility isn't just cost, it can also be users changing their requirements all the time, and the situation changing all the time. So we've been quite good at managing uncertainty as project managers. So we've got risks, or uncertainties are quite often expressed in terms of risks, and there's basically three types of risks we have. There's a known unknown, so that's the uncertainties that we know exist in the project. So usually to do with price or cost, I think, is the easiest to understand. So we know we might need some labour resource in the future, but we just don't know what cost that labour resource is going to be. Or we may know that a system has to do some complex analysis of data in real time, but we just don't know how complex that analysis will be at this point. So it's very difficult for us to predict the time or cost of a component, but we know that component exists. Known unknowns are things like classic risks on the risk register. So these are things that may or may not happen in the project. So it may rain, or we may have problems importing goods. But we don't know if those problems are going to occur or not. So they're knowns, the things that we understand, but we just don't know if they're going to catch us out on this project. So that's what you see on your classic risk register, and we can estimate the probability and the impact, and we can make allowances in terms of the way we manage those uncertainties. The black swan risks, or the unknown unknowns, are the famous Donald Rumsfeld risks. So these are the risks that no rational person could have predicted at the beginning of the project, and they're just blindside risks. So we normally manage these through some form of management reserve or overall contingency that we add to the project. So we know it's high risk, so we better add a bit of bunce, I expect people might call it, some spare money, just because we know it's a high risk project. So what's complexity? So complexity is basically comes from the combination of all the different components and the interaction of those different components in an unpredictable or uncertain way that makes it very difficult to take decisions. Now that's quite a difficult concept, but Steve Wozniak, I was watching a video the other day, and he was describing how when he started work at Apple with Steve Jobs, one person could understand everything that was going on inside a computer. They could understand the processor worked, how the software worked, and how the hardware worked, and how they might be a clever person, but it was conceptually possible for one person to understand the whole system from a hardware to a software and how it's delivered. Whereas nowadays our systems, computer systems that we use, are so complicated that you need specialists in each area. Now the graphic user interface, the way the hardware works, the way the software works, the way the operating system works, the way the programming languages work. So even in that narrow field associated with just the way a computer works, nowadays it's much more complex than it was previously, because no one person, you can't get everybody in the room who understands it. And then if you take a project outside, and you say a project may have IT components, it may have physical components, it may have people-related process regulation components, then you get that complexity from all those different skills coming together. So what's ambiguity? Ambiguity is two people look at one thing and they see different things. So when you look at this picture, do you see a vase, or do you see two people looking at each other? So it's the same information, it's just different people interpret it in different ways. So it comes from the Latin ambi, which means both ways. You can see it in multiple ways, so that makes it very difficult. So we've dealt with ambiguity a long time, and that's about taking intuition, using intuition to take the right decisions. But when you combine all these things, you end up with quite a very difficult project to manage, because it's volatile, uncertain, complex, ambiguous, and so it's really difficult for us to manage the project. And various people have sort of come up with different ways of doing that and processes of doing that. The one I like, this is my little model, is you have to create some model of stability, some small island. We can get on with this little bit and achieve something. It's the same concept you see in Agile, and the same concept you see in program management, where you have an evolutionary approach to the delivery of the project. The world out there might be very complicated and difficult, but at least we can take the next step, and as a result of that next step we might learn something. And one theory that's widely used in development projects is the theory of change. I quite like the theory of change. What that says is you may not be able to achieve this long-term goal, and actually many of the participants in the change may find that long-term goal a little bit daunting. So what we can break that long-term down into intermediate outcomes, and these intermediate outcomes can be linked to each other, and if we can make sure that those intermediate outcomes support that long-term goal, then it may be good enough that we just achieve an intermediate outcome for now, and then having achieved that intermediate outcome, we'll get some success and some learning, and so from there we can understand what our outputs, funding, skills and human capital requirements are to achieve that intermediate outcome. And that's like a really brief overview, and I've probably got it all wrong of what is quite a well developed. So this is a technique used by people like the World Bank for development projects in quite volatile environments. So that's my summary of VUCA and how it might apply to projects that we're managing today, and I hope you find that summary quite useful. And if you have any questions, please do comment, subscribe, get in touch.